Welcome to the project demonstration of three-phase induction motor protection from phase fault and high temperature. So here we are demonstrating these 6 bulbs which will represent the coils of three-phase motor. So three-phase motor consists of R, Y, B phase coils, and two bulbs will represent the each phase coils. And here we are providing the protection to this three-phase induction motor presentation. So one way of protection is like phase fault. So means whenever we are providing 3 phases to a 3-phase motor, then the 3 coils will get proper phase shifting currents, then it will rotate. So by case any phase fault occurred, so in 3 phases any R, Y, B or any single phase fault occurred, then the 2 coils may take high load and the motor may get damaged, so which will leads to the high cost loss for the industry or irrigation. So in order to prevent that loss, we need to protect the particular motor from two-way protection, that is single phase fault. So means if is any phase fault occurred, so either R, Y, B, then we need to isolate the total coils power supply. Nothing but we need to shut down the motor, means we need to disconnect the motor from the 2 phases along with the fault phase also. And whenever the 3 phases again back to the picture, means when they are active all the phases, then again we need to allow the power to the phases to on the motor. And the second protection is temperature due to high load. For example, if we are using that particular motor in irrigation side, so due to dry run or any load occurred on pumping of the water, then the coils may get heat up. Or in industrial cases, for example, if we are running any conveyor belt due to any heavy load placed on the conveyor belt, or if is there any certain struck inside the conveyor belt, then the motor coils may get heat up due to the high load than the normal case. So then also the motors may get damaged. So again you need to protect that from overheating protection. So first is single phase protection, means phase fault protection, and the next is overheat protection. So for that purpose we are making use of this temperature sensor, so which will continuously monitor and maintain the temperature and the threshold value. So whenever it crosses the threshold value, then it's an indication of overheat due to any reason. We are not supposed to make the coils to be get heat up. So that will be done on microcontroller. So the microcontroller will continuously measuring the phases availability, and when the 3 phases are active, then only the system will on the these relays, electromagnetic relays. So 3 relays are representing the 3 phases power supply R, Y, B. So when the 3 phases active, then 3 relays get switched on, so that 3 phases will be connected to the 3 phases of coils of the AC induction motor. Same regarding the temperature also. When these 2 are satisfied, so there are 2 cases. One is these 3 has to be active, and the next condition is the temperature should be normal. So when these 2 conditions are satisfied, then only the system will on these 3 relays. As well as same will be represented with the help of these 3 LEDs, which will show the status of active phases. So if R phase was off, then the only red LED will be off, remaining 2 will be on. So which will show the phases status, which one is available, which one is deactivated. And the next, these 3 sources which will acting as a regulated power supply boards as to check the 230 volts, because we know that phase 2 neutral voltage is around 220 volts. Whenever we want to check the 220 volts availability on the particular phase which is given to the coils of the AC induction motor, then the microcontroller can't measure the 230 volts AC directly. That's why we are making use of these 3 regulated power supply boards, which will convert the 220 volts of AC to 5 volts of DC. Whenever the primary side is 220 volts AC is available, then the output side will get the 5 volts DC. If the 5 volts DC is available to the microcontroller, that will indicate it, okay, the particular phase was available. Same for the remaining phases also. So here we are representing single phase to the 3-phase representation, as we are unable to get the 3-phase now for demonstration purpose. So just we are converting the single phase to 3-phase. So now let us see the demonstration. So when we on the power supply, right. So initially these 2 lights along with this light should have on. So if it is continuously not blinking properly, then just disconnect the power and connect it again. Now, so all phases are active. That's why the three phases are getting power supply, 6 bulbs are on, as a 3 relays also on. We can see the status on this relays. So while demonstration, you can see the light on, these light on, this light on. So that's parallelly total 3 phases are connected. Now, so while demonstration, you are not supposed to touch over here because the circuit totally flows with 220 volts of AC. That's the main precaution point. And now, whenever any phase fault occurred, right? So the total at the same time within 100 milliseconds, the relays will get switched off to protect the motor, and we can see the red phase is not available. Again, when it is come back to the picture, then automatically the relays will be connected, the coils, to the 3 phases. So Y phase fault, and this is blue phase, B phase fault. Right. Coming to this is the phase protection, phase fault protection. And next, coming to the temperature. Just whenever we increase the temperature, you can use your matchbox or some other to heat up the temperature. So when it is getting heat up, you can see the green light gets switched on, which is indication of, it's called threshold value. Now it is off. So this is the normal and abnormal conditions due to overheating done by the temperature sensor, and phase fault with help of the switches, and presentation of the availability phases, active phases using the LED indications, and relays to control the phase power supply connection to this coils of the AC induction motor. Thank you.